Alright, so today we're going to talk about oxidation numbers. We're just going to title these notes Oxidation Numbers. Okay. Let's think about oxidation for just a second. What do we know about this word? Have you ever seen a kind of an older red car and it sort of looks pink? Yes. The paint has oxidized. Okay, we know that word. Yeah, when copper turns green, it's oxidized. Or when silver tarnishes, it's oxidized. Or when metal rusts, that's another form of oxidation. So what is actually happening in those situations? What is going on? Well, if we look, we see oxy here. Okay? So that has, we think automatically oxygen. And that's sort of a rabbit trail that we'll come back to here in a second. But remember, when we thought about electronegativity just a second ago in our bell ringer, oxygen is pretty high on the electronegativity. So those electrons definitely have to do with oxidation. So let's go ahead and write down oxidation is the loss or gain of electrons in a compound. Okay. This number is not going to always be the same for every element. So that's where the kind of confusion comes into play when we try to write oxidation numbers, because it is a relative number. I don't mean relative like it is related to someone. I mean relative like it is in relationship to the other elements in the compound. Okay. So we should go ahead and be really clear and say it's not always the same. Okay. Alright, we have 4 rules that we need to write down for oxidation numbers. The first rule is the oxidation number for any lone element is 0. The oxidation number for any lone element is 0. Okay. So let's kind of think through that. If I have potassium hanging out, elemental form, its oxidation number is going to be 0 because it hasn't lost or gained any electrons in the compound. It is completely equal in electronegativity. It's not going to steal any electrons from its neighbor because they're all the same. Okay. Same thing if I have aluminum. That seems obvious, right? We have aluminum, it's elemental, it doesn't, oxidation number of 0. There are a couple of things to make sure and know. If I have oxygen, even though it has a subscript, so it's in a molecular form, the oxidation number is still going to be 0 because it's an element. Because they're still the same. They have the same electronegativity, they have the same pull on the electrons. They're not going to take away somebody else's electrons or give away their own. Same. I'll go ahead and give this example here. There's 8. That's weird. We don't normally see numbers like that. But they're still all the same. They're still all the same. So that oxidation number is still going to be 0. Okay. Cordell, write these notes down, okay? Alright, number 2. That's the first rule. The second rule. This one's a long one, so bear with me. Oxidation numbers are usually assigned to the most electronegative elements first. So, oxidation numbers are assigned to the most electronegative numbers first. Okay? So what that means is that the most electronegative elements are going to more regularly have the same oxidation number. So for instance, fluorine is always, now that's a big word in science, always -1. Because it is the most electronegative, it is always going to have the same number. Okay? Oxygen is also very highly electronegative. It is, I'm going to make this one lowercase, okay? Always -2, unless, now this is more normal in science when we have an exception, unless it is with fluorine. So because fluorine is the most electronegative, it can kick oxygen off of its always. Okay. Alright. And then, yeah, this one is a little bit longer rule, but we're going to say that the others, so fluorine and oxygen, we can come to almost all the time. But the others are assigned based on the ion formed. The others are assigned based on the ion that they form. So let's pause for a second. We've got a couple of cheat sheets, and we're going to kind of look at those. Our first cheat sheet, as always, is our periodic table, right? We said that group 1 will make a +1 ion. Group 2 will make a +2 ion, okay? So we could write that down, okay? Group 1, or group 1A is a lot of people. Group 1A is going to usually make a +1 ion. Almost always, but okay. Group 2A will usually make a +2 ion, and so on. So like we could go on this periodic table and we could say, okay, this one's usually going to be a +3, this group is usually going to be a -3, and so on. Okay. So I also want to bring out the other cheat sheet that we have used a lot. Looks like this. Common ionic states of elements. I wrote across the top also common oxidation numbers. Notice I highlighted common because they're not always the same, but if we use this cheat sheet that kind of has the ions that they form, we can kind of get a good guess to start with. So that's what that one means. Right? So that's the second rule. We'll come back to that as we try to write oxidation numbers. Okay, but the third rule is all about hydrogen. Okay, hydrogen is a +1 with nonmetals. Anytime it is bonded to a nonmetal, then it is going to be a +1. But hydrogen is a -1 if it is only with metals. So hydrogen is a -1 with only metals. So this is kind of like a riddle puzzle you have to figure out when you're looking for oxidation numbers. Alright. Last rule, number 4. Number 4. The sum of the oxidation numbers equals the charge. So the sum of the oxidation numbers equal the charge of the molecule. Often that's going to be neutral. So what is the numerical charge of a neutral molecule? Zero. Neutral equals 0. Okay. Alright, so I'm gonna, while you're finishing writing that, I'm gonna go ahead and pull up the practice page. Alright, so if we look at our practice page we have, it asks us to find the oxidation number for all of the elements in the compound. So here's number 1, and we had A. So 1A is sulfur and oxygen. Alright. First thing that I need to look at is what is the charge of this molecule? Well, I don't see any indication, so that means it's neutral. That means it's a 0. So I can go back to the other rules and I say, alright, this is not a lone element, so I'm going to skip that one. But, so oxidation numbers are assigned to the most electronegative numbers first. I have instructions about F, and I have instructions about O. So oxygen is always -2 unless with F. Alright, well, that means I do not have fluorine in this compound, so that means the oxygen is -2. There's only one of them. Alright. Now I have to think to myself, okay, what am I going to do here? The sum of the oxidation numbers equals the charge of the molecule. So I know that it is neutral. I'm going to say, okay, 0 equals, I only have one oxygen, so that's -2 plus. Alright. What do I need to do to find what gives me negative, or what gives me a 0? It's a little bit of algebra, right? So what plus -2 equals 0? +2, right? So then I know, okay, well, the oxygen was -2, so the sulfur has to be a +2. Does that make sense? Kinda? Okay, let's do some more examples. So on the worksheet, we have SO2. Now on this first example, it's going to be all sulfur and oxygen so that you can kind of see that it's not always going to be the same number. So we're going to go through some of the same thinking. On this sulfur dioxide here, I don't have any indication of a charge, so I know that it's going to be a neutral charge. Alright. I go back to the rules that I had. I know that oxygen is always -2 unless with the fluorine. So I know that it's not with the fluorine. But this time, I have 2 oxygens. So I know my total is 0 because that's the charge. But every oxygen is -2. So I'm going to say -2 times the subscript of 2. That gives me -4. So then my sulfur, I got to figure that out. I cannot just go back to my cheat sheet. Because let's kind of look at that. If I go back to this cheat sheet and I say, well, sulfur is -2. If I put a -2 there, is that going to equal 0? No. So I got to start with oxygen. What does sulfur have to be in order for this to equal 0? 4, right. So hopefully you're starting to see, oh wait, this is just kind of like a puzzle. Sulfur has to be +4 there. Okay, alright. Well, let's go ahead and just do all the ones from that first example so you can see some different things. And actually, yeah, let's do it. So we should kind of be getting the hang of this a little bit. We see that it's a neutral element, or neutral compound, so we're going to say 0 equals something. Well, I know oxygen is -2 unless it's with fluorine. I have 3 of them, so I'm going to say -2 times 3 is -6. So what does that leave sulfur to have to be? +6. Okay. Give me a thumbs up if it's starting to make sense. Better? Okay. Alright, let's keep doing it well. So we had some sideways thumbs and some down thumbs. So let's do D. So D says, now very similar to C, but SO3, and this time we have an indication of a charge, -2. So if we look back at our fourth rule, sum of the oxidation numbers equals the charge of the molecule. Well, this time I'm going to have it say equals -2, because that's what my molecule is. So I go through the rules. I know that oxygen is always -2, unless with an F. There are 3 oxygens. So -2 times 3 is -6. Okay. So to make this math sentence correct, what does S, the one lonely sulfur atom, what does it have to have? I saw some people holding up 4 fingers. So +4 plus -6 is -2. Okay. So it's kind of interesting to see that with the charge, this polyatomic ion, sulfur has an oxidation number of +4. But when it is neutral, as just a compound or a molecule, we have +6. So that's important to realize. It's not always going to be the same. And let's go ahead and just do E for completion, and then we'll do a couple more examples so you have good notes. E is very similar in process. Okay. So we know we've got this charge listed, so we're going to end up equaling -2. We know that oxygen is always -2 unless it's with fluorine. So -2 times 4 is -8. So what does sulfur have to be here in order for this math sentence to be true? +6, right? Alright. Give me a thumbs up if that's kind of making sense. Alright, good. We are going to do a couple more examples just to kind of make sure that we're really clear. I wanted to scroll down to, let's see. If you look in your work here, number 2 is very similar. You're just using chlorine instead of sulfur. Number 3, you're using nitrogen instead of sulfur. Same concepts. I wanted to come down to number 5 because number 5 we have 3 elements. So let's go ahead and do a couple of them from 5. I'm going to flip my paper so we can have enough space. Alright. So number 5, and we'll just get started. A says HP O3. So we have 3 elements here. We're going to go back to those rules that we had. And we know about oxygen. Okay, we know that there's no charge listed here. So let's set it equal to the charge. We know that oxygen is going to be -2 because there's no fluorine there. So -2 times 3 is -6. And then we don't have a rule for phosphorus, but we do have a rule for hydrogen. So if we go back to our rule for hydrogen, we said that hydrogen is a +1 with nonmetals. Hydrogen is a -1 with only metals. Alright, well, these are both nonmetals, so that means hydrogen has to be a +1, and there's only one of them. So we're going to have +1 plus something to equal 0. So what number do I need here to make this math sentence correct? 5, right? I need a +5. So then I look and there's only one phosphorus, so the oxidation number of phosphorus is +5. Okay. Alright. And we'll just do a couple more of those. I think let's go ahead and look at C. Because B is, I don't know why I skipped B, but let's look at C. C says H3PO2. Alright, so we have 3 elements, we have all the same elements, so we already get to use a lot of the same thinking that we already did. There's no charge, so we know it's 0. We can set this equal to 0. Okay, oxygen is a -2 because there's no fluorine around. So -2 times 2 is -4. We're going to go through the same thinking steps. These are non-metals, so hydrogen has to be a +1. But now this time, we have 3 hydrogens. So we're going to have +3 because 1 times 3 is 3. So in order to make this math sentence correct, what do I need right here? +1. So phosphorus has an oxidation number of +1. Okay. Alright. I wanted to go through one of these ones with the bigger numbers. Let's go ahead and look at F just because it looks kind of weird. Alright, so we don't have any charge here, so we know that the charge is 0. So we can set this all equal to 0. Oops, I probably wanted to come down here. So we'll move our line down a little bit. So we know that there's still no fluorine, so oxygen is going to be -2. -2 times 10 is -20. So don't let the big numbers throw you off. We're still doing the same thinking process. We still have hydrogen with nonmetals, so it's going to be a +1. But I have 5 of them. So what does that make phosphorus? What I need to make this math sentence correct is a +15, right? But I have 3 phosphoruses. So you're right. I have to divide 15 by 3 and I'm going to get a +5 for my phosphorus. So just be really careful that you're doing the full thinking. Like these 3 phosphorus atoms are providing the +15. So each phosphorus atom is a +5. Right? so be careful of that. Give me a thumbs up if this is making sense. Like, you got this. Alright. I want to do one more example. I know you're like kind of done with examples, I can tell. But I wanted to come down to this one at the bottom that has a parentheses in it, just to make sure that you are fully thinking through. So it is L down at the bottom. We're going to go with iron 3 oxide. And there is no charge, so we're setting it equal to 0 again. Okay. We have no fluorine anywhere, so we know that oxygen's going to have a -2. We could make the leap and talk about hydrogen. Now, this is important. Iron is a metal. Oxygen is a non-metal. If we look at our rules, we said hydrogen equals +1 with nonmetals. Hydrogen equals -1 with only metals. Because that oxygen is there, it's going to be a +1 because there are nonmetals present. So, how many atoms of oxygen are there? 3. I saw some fingers. Alright, so -2 times 3 is -6. How many hydrogens are there? 3 again. Now, what does it take to make this math sentence correct? -6 and +3 is 3. There's 3 left, so I need, there's a -3, so I need +3 left. So that means that my iron has to be a +3. Alright. I feel like there was a lot of people who had thumbs up on that. So let's kind of look at, I know there's a lot of problems here. Okay, and we have plenty of time, but I want you to have some time to finish up CK12. So,